Dear friends, welcome to Infos. Welcome to Oil and Gas Training Series. Welcome to Gas Processing Part 4. As you know that one, we have already completed gas processing system, video 1, 2, 3. So today we are discussing about gas processing Part 4. This is my 37th video. So kindly request all of you to watch all my previous videos to get some clear idea on oil and gas operation. So let us discuss on gas processing in detail. If you didn't watch gas processing 1, 2, 3, so you will confuse in between this gas processing part 4. So it is always better to see all videos in regularly. So your basic knowledge and understanding will be very clear. So natural gas processing. In when I have discussed in last class like that one, gas sweetening we are taking today here. Removal of H2S and CO2 from natural gas using an aqueous solution of amine using the process absorption. H2S and CO2 is further removed from amine solution by regeneration process, reused further. This already we have discussed in last class. See, so let us go in details and what is happening here in operating cycle. Simple flow schematic diagram. See, this is the absorber here. So source gas is coming with H2S and CO2. So natural gas plus H2 and CO2 is coming here, entering to the absorber. We have discussed about what is absorber and internals, all details of the absorber in gas processing 3. So I will add that one into the description area, that about gas processing 3 link. So you can watch easily on that one. So in absorber, gas is going up and lean amine solution is entering to the top and passing down. So counter current flow reaction pattern is established here. So then H2S is absorbing by in amine solution, and the purified gas, so the lean gas, that is hydrocarbon, pure hydrocarbon gas is getting releasing from the tower from the top, and lean rich amine solution, that is amine plus H2S solution is received in the bottom of the tower, and it is taking out from here. So then this will making heating, and this area we call the regeneration process. This area is a regeneration process. What is happening in regeneration process? The H2S and amine is here, and boiling point of H2S and amine is different. So we are preheating here, and we are entering a column is called stripper. It is another type of a distillation type column, using a boiling point difference here to release the acid gas out of the tower, out of amine, and making amine pure. That is a process here. We will discuss that process in details in coming slides. So so amine is entering here, and amine traveling to bottom of the tower, and from the bottom of the tower amine is taking from some portion of the amine is taking from, and you passing through a reboiler to provide a required heat of this process, and that amine vapor, amine plus H2S, H2S vapor from amine, it is boiling up and releasing. H2S and water vapor is slowly moving up. By the time the rich amine solution, liquid solution coming down, here also counter current flow is established, and that is releasing, the acid gas is releasing here. That acid gas is purely H2S, and a little bit water particle is releasing here. That actually cooling back, and some portion of this one it will re-enter here. So that way, if late gases is releasing here, amine solution, pure amine solution without H2S is settling here in the bottom of the tower and slowly overflow to the next section of the surge drum here, and I will explain that one in detail. Then it is cooling here, again pumping, cooling here, again it is entering here. This is the process. So pure gas is releasing to the next operation section, and amine is recycling in regeneration section. In generator, acid gas is removed and pure amine returned back to this absorber. This is the process. Let us see in details what is the process here. Acid gas, this is already we have explained. So what is the process is here? Separation of H2S and CO2 from sour gas. H2S and CO2 is called acid gas. Highly corrosive in the presence of water. So that is the one reason we are removing acid gas. Highly corrosive in the presence of water. Toxicity, that is a very extremely high toxicity. Lack of heating value of CO2 and sales requirement. So this is the reason for acid gas absorption, removal of acid gas, the gas sweetening process. Selecting amine process. Lean amine absorbing acid gas H2S and CO2 from natural gas to make sweet gas. Cooled lean amine flowing to the bottom from here. Lean amine from up to bottom. For flowing top to bottom, rich gas is flowing from bottom to top. Absorption process taking place with perfect contact inside the tower. Lean natural gas is releasing from the top and rich liquid is leaving from the bottom. Rich amine solution is collect to the bottom and regenerate for reuse. This is the amine process. And another one is a selection of amine. Various type of amines are available in the market, and a suitable amine selection is either monoethanol amine or diethanol amine. Let us see which one is best. High absorbing monoethanol amine is high absorbing capacity of toxic gases, where a high degree of gas purification is required, more vaporization losses, reaction with acid gas other than H2S and CO2, forming undesirable salt in contacting tower. Whether while DEA, diethanol amine is best suitable amine for all type of operation condition, capable of achieving a high degree of gas purity, less hydrocarbon contamination for the acid gases, lower operating losses, less degree problem. So always most of the companies are operating companies are selecting diethanol amine or DEA for amine process or gas sweetening process. So let us go process description, how it is there. I have just to marked blindly here this section, and now we are looking the absorber section. See, look at here. Sour gas is entering, going the yellow red color is going up. By the time this is amine entering, that is a blue color coming down. So what are the conditions are here, and treated product is receiving here, and rich amine is receiving here. High pressure and low temperature operation in absorber. So in absorber, the main important two process variables are pressure and temperature. It is high pressure and low temperature. In the intimate contact of lean amine and sour gas inside the tower enhance maximum absorption of acid gas by lean amine. So intimate contact providing by the bubble cap trace. Internals are arranged in such a way that one. So intimate contact is enhanced to maximum absorption of acid gas by lean amine. Sweet gas releases to further process from top to rich amine to collect the bottom. So sweet gas is releasing from the top and rich amine is collecting from the bottom. So this is the process of absorption. So look at here, a regeneration process, what happening. This is a regenerator. Regenerator is a stripper. Sometimes we called stripper. Sometimes we call amine still column. Some means called boiling regenerator section. So rich amine is entering from the top or maybe one tray down, and it is the blue color is coming down, some portion taking to the reboiler, and that vapor, light vapors, H2S, CO2 vapor, some part of water particle also moving up. So hot vapor is moving down, moving up, and rich liquid is coming down. So exchange heat between that one, because of the boiling point difference, acid gas is moving up initially, and rich liquid is settling down because of the boiling point difference. So acid gas is condensing through a condenser and accumulator, collecting the accumulator here, and in that accumulator acid gas is going releasing to the another section, H2S recovery plant, acid gas recovery plant, and rich water vapor, water particle or water liquid water is collecting here and refluxing back to the still column, stripper column, to maintain the temperature here. So this is the process in amine replacing, and rich amine is collecting here. Some portion is always taking out, pure amine is taking out and pumping back to absorber. So this is the process. Rich amine regenerate in stripper, that is called a regenerator. High temperature, low pressure. High temperature operation, it is around water boiling at up to the temperature of just above the water boiling point, it is around 115 degrees C. So, and pressure is atmospheric pressure, low pressure operation, just opposite of absorber. Amine solution flowing downward through the still to the reboiler. This is the reboiler. Reboiler is the driver of this column, that is providing the energy of this still column. Reboiler heated up to 110 to 115 degrees C by vapor rising from the reboiler, the vapor rising up the boiling solution in the reboiler. So the vapor is going up and the liquid amine is coming down. Acid gas is flashed off in the top from the rich solution and water vapor generator during the stripping. So during the stripping process, acid gas is flashed off here in the top. Water vapor is condensed. Water vapor is condensed in the reflux and separated in the from the acid gas in the condenser. So water vapor is condensed in the accumulator and collected back and reflux, sending back to the reflux system to the stripper. So this is the simple process description. Condensate is pumped back to the top of all the generator. So this condensate is pumped back to regenerator again. Acid gas is sent to sulfur recovery plant. So acid gas is further sent to making, some of the companies are making liquid sulfur, some companies are making powder solid sulfur using for fertilizer plant or using manure for the trees, agriculture industry. So some more elaborated detailed process flowchart. So look at that one. Absorber is there. Go ahead from inlet. Inlet sour gas is entering from a knockout drum. Knockout drum is releasing any unwanted material like moisture, water vapor, or solid particle. Anything is there, it will pure gas component will enter here. So this is a very good system for supporting this performance of absorption properly, increasing the efficiency of this one, inlet knockout drum. This one. So it is all what is liquid contaminants, whatever the liquid contaminants is there, collecting that bottom, and we can releasing frequently using a level control system. And sour gas is entering here. This is, we have already discussed that one. So whenever the sweet gas is releasing up, it will again the exit outlet separator or knockout drum. So again further any solvent is there. In case amine is carrying with carry over with sweet gas, in that case we can collect the amine back here. If amine is losing, that will we will losing money. So always we have to collect amine back regularly from the exit system, so that amine will collect here and using the inlet plate and using the demister pad. This is called a demister pad. Both system it will pass that one, whatever the liquid, heavy liquid amine is collecting here bottom, and we can separate using a level control system. So that is the absorption system. So once a rich solvent is collected here, that rich solvent is collecting a flash tank separator. In that one, it will, any gas is carrying with amine, that we can separate here, plus any liquid hydrocarbons are there inside this one. Any liquid hydrocarbon is there, condensed with or dissolved within in this amine system, that also we can collect it. So like a three-phase separator, and liquid amine, rich liquid amine is collecting here, and it will go to a using a mechanical filter if it is required, or we can bypass it. And now this here it is a low temperature operation. So because of that one, the temperature we have to increase, amine temperature we are increasing, because here it is a high temperature operation. So liquid amine is heating with return amine, that I will discuss later. So this is called a lean rich amine heat exchanger. This is a one side it is entering lean amine, other side it is entering rich amine. So that will enter to the stripping process. This already I have discussed that one. So it is amine is collecting to the reboiler and providing the heat energy back to the stripper, and light H2S and CO2 with water vapor releasing to the accumulator. Accumulator is same process is taking from a condenser. After the condenser it is separating, and the gas condition gaseous H2S and CO2 releasing back. Then water is reflexing back to the system. So here it is rich amine is here, rich amine is lean amine is taking back to here. Here it is again, it is now cooling back to the system, because here it is a low temperature, here it was high temperature. It is a lean entering from a lean rich amine heat exchanger. Then it is a surge tank for maintaining the level. Again it is cooling. Then it is two type of filtration, because amine contamination can performance affect the performance of the absorption. So that's why it is two type of filtration system. Then amine going back. Take your time and study this one, and if possible in YouTube natural gas sweetening videos are available. I will try to add one link of that one, and you have to watch this one. Definitely you have to watch this one, you will get a better idea. So some of the factors affecting in absorption section process: adequate to solution circulating rate and correct concentration is very important. Circulation rate, that is the this amine circulation rate, amine entering to the system, the quantity of amine entering to the system, and purity. That's why this filtration is here. Here one filtration, here two filtration is there. That is why that filtration is there. Circulating rate proportional to the sour gas. How much sour gas is entering to the system? According to that one, we have to fix it the circulation rate. And solution concentration, we will provide, if it is getting solution maximum concentration, it will get optimum performance we will get. And the temperature of the incoming amine, another important matter. I already showed that one in the previous PFT. So three type of heating systems are there, heating and cooling systems are there. So temperature of the incoming solution slightly above the temperature of the inlet gas. It is always, it should be slightly above the temperature of the inlet gas to prevent the condensation of certain hydrocarbon in absorber. Best scrubbing result maximum solution losses. So temperature is very critical process variable in both absorber and stripper. Liquid level in the bottom of the contactor in the absorber. Ensure carryover and foaming inside the tower. So liquid level is also very important. Carryover in either way, gas carryover with amine, amine carryover with gas, both in either way it is affect the performance of the absorption. Good maintenance of contactor internal. We have discussed about internal. So internals should be always in good condition. Frequent maintenance, replacement and repairing, so etc. It will improve the performance. Prevent the free passage of gas and liquid from one tray to another. Poor scrubbing efficiency. And moreover, operating variable in the absorber, pressure and temperature, circulation rate and gas flow rate, and contamination concentration level. All variables are very important, and in the stripper it is temperature is very important. Temperature and pressure is very important, and purity of and internals maintenance also very important. And operation problems, losses and corrosion, gas flow and pressure, it is very important. We have discussed that one. Falling below a specified design range will result in loss of efficiency. So gas flow and pressure. Rising above the design range will ensure amine carryover, will result amine carryover. So low pressure in absorber will result loss of efficiency, and flooding will start. Rising above the design, if it is high pressure, definitely amine will carry over with gas. Lean amine temperature, that is very critical. The solution temperature must be kept at least 7 to 9 Fahrenheit or 5 to 7 degrees C above the incoming sour gas temperature to prevent hydrocarbon condensation, which causes foaming in the tower. Liquid carryover create a number of operation problems including foaming, equipment fouling, high corrosion rate if liquid carryover is starting. The result, loss of efficiency, solvent amine loss, solvent loss, and difficulty in meeting sweet gas specification. Amine decomposition in stripper, if it is extremely high pressure heating above 280 Fahrenheit, then amine excess temperature in generator create amine decompose. It will lose its all property of absorption. So amine recirculation rate and concentration, loss of efficiency, amine loss. Corrosion, high temperature create oxidation in amine. Oxidation of amine means corrosion. So these are the various operational problems facing in that one. I hope you have to understand the gas sweetening well. Let us review it again, and taking another important part of control system P&ID review. Many classes are on the way. So please subscribe this channel for a timely updation, and please join our Telegram channel Infos.by HAMSA V BAVA. Thanks for watching this video. Definitely we will come back with the gas processing section 5 soon. Thank you for watching this video.